two videos discussing the EPA SOAP Toolbox. This video will be more on extending the SOAP Toolbox into the XP Solutions environment, specifically into XP SWM. Let's go ahead and get started. So here's the agenda for today, hopefully about the same time as last time, maybe about an hour or so. We're going to start with a quick review of the last video, and then we're going to cover some common workflows in connecting EPA SOAP to XP SWM. Then we'll discuss tools to help make those workflows a little bit better, hopefully. And then we'll go into a demonstration about how to actually run through the common workflows. So the first thing is the review of SOAP. This was about an hour-long presentation, and you can see a link to it right there, a YouTube link. You can also find that link on our website, xpsolutions.com. Basically, the purpose of the first video was an introduction to SOAP. So this is software agnostic. No matter what you use, it just shows you how to use all the common SOAP pieces. So if you are unfamiliar with SOAP, or you haven't watched it in a while, you may go back and watch that first and then come back here. And again, SOAP basically is a simple, straightforward way to use rainfall data and flow meter data to estimate RTK parameters for wet weather flow. And certainly there are other things that SOAP can do, but generally speaking, that's the main use case of SOAP. However, today's talk will be more on the workflow of SOAP inside a broader sanitary sewer modeling effort, which of course requires a lot more hydraulic work and a lot more evaluation. And I think of two main ways that this workflow occurs. And they're both very valid, and they both happen for different reasons. So the first way would be there's some type of meter installation of flow meter and rain gauges, and then there's calibration. So when I say calibrate flow, I mean RTK parameters are developed and everything is calibrated to the individual meters before the model even really begins. And after you've done that work, or after you've certainly gone significantly through that work, then you develop the model and you continue down that path. Another way you might do that is to develop a more bare bones model that would have a little bit potentially of flow and meter data, and use that to locate additional meters. So maybe you had historical data, now you're locating newer meters, and then you're going to do a new calibration. And again, there are reasons to do either one. And I'm just pointing out that that generally starts two different ways. So the first one is doing a lot of your work in your initial data scrub in SOAP, and then putting that to XP SWM. Second version is the opposite, doing a lot of your initial data scrub in XP SWM, and then conveying that work to SOAP. And of course, it's typically not that cut and dry. There's usually some iteration. So something doesn't line up when you're only looking at hydraulics and then you look at flow, or vice versa. When you're only looking at flow and then you look at hydraulics, something else is uncovered that requires some type of back and forth. So it's not just a linear workflow. But let's talk about that first workflow, which is the EPA SOAP Toolbox to XP SWM. If we build SOAP first, then we're taking probably raw or somewhat raw data in the field in different formats and casting it into a database. The three biggest things that the SOAP database would have, assuming we did that work, that XP SWM would want, would be rainfall data, flow data, and the actual RTK parameters. Those are three things that if we do the work in SOAP, we'd like to get it into SWM. And if you look on to the side, you can see some goals here. Because of course, there's no reason you couldn't do this manually, right? There's nothing stopping you, and a lot of users currently use SOAP and SWM together. But we're going to list 6 goals here to try to make this even better. The first is to be efficient, and using the acronym Don't Repeat Yourself. So if we're going to go through the effort of getting all the data into SOAP, there's no reason to go through the effort again in the SWM. We also want to be consistent. We don't want to have any problems with units or timestamps or otherwise. We don't want them to be run in two different ways. Certainly there are lots of real and apparent errors in modeling, and we don't need to add this type of transcription error as an additional error. We'd also like it to be repeatable. So if we have to run this more than one time, that we get the same answer every single time. And we want it to be documented. So we'd like this to be documented for other users within the organization to use it, as well as clients who consume the data. We want to make sure that anyone who sees it sees that there's a well thought out way to get the data from point A to point B. And of course, if we're going to go through all this, it'd be useful to have it be faster and easy, because tools typically are used if they're fast and easy. Very similar if we're going from XP-SWM to SOAP. The only difference is you would probably not be determining the RTK parameters in XP-SWM, but you would be entering in all of the sewer shed data in SWM. But otherwise, you would have rain and flow, same idea. And if we're going to get it in a nice format of XP-SWM, potentially using the better converter of XP-SWM, then there's no reason to not push it out to SOAP. There are other reasons to do that too, of course, including small things like updating the data logs automatically, or doing things like updating the holidays, because EPA SOAP is not going to have the last 2 years of holidays. So if you're using that as part of your evaluation, little things like that are very easy to update automatically and consistently. So you may ask yourself, I'm on board with what you're trying to do, why can't we just use the open database connection and connect everything that way? That would seem to be more straightforward, and it would be more straightforward, but there are a few reasons why we can't do that that efficiently or really effectively. The first is the way that the two different softwares store their objects. And I'll give the example of rainfall. So because EPA SOAP is looking only basically at rainfall and flow, it treats rain differently than XP-SWM does. So rain is a main input into SOAP, whereas it's a global database that is fed into the junction in XP-SWM. So it handles that differently. It also handles operations differently. There's not really any memory type operations in SOAP. It's all written to disk directly, versus XP-SWM that does a lot of operations in memory. So the way that it stores some of the data as you're calculating things make it a little more difficult. And because it stores the data differently for different reasons, the schema of the database is different, which again you'd expect. But there are some issues with cardinality and other things that just don't make it that easy of a fit to go from something like the time series of rainfall that is stored differently in the two different datas. But that's okay, because both softwares are well developed, so it can be done in a repeatable fashion, just not this way. So how can we do it then? Well, let me talk very briefly about the different database types. So EPA SOAP is an open source. I believe it's Borland software was used to write it, and you can get the source code from the EPA website. It uses what I believe to be an Apache OpenOffice. That is the SDB extension. You may or may not know that Microsoft Access can open that extension, and if you save it as that 2003 version, the .mdb, you can actually open that back up in EPA SOAP. So there's some interoperability between those two types, which is good because we'll use that to our advantage in what we do. I'm a big fan of SQLite, and so you see the extension DB3. You may also see that as DB, SQLite, or SQLite 3. It's also an open source embedded database that has a pretty nice set of tools. And then you see the XP database. So our workflow of SOAP to SWM in this case is basically moving from the OpenOffice database to the XP database and back in that order. And you can reverse the order for the different workflow. So the tools to use that, I'll be using the SQLite command line, which is just a really small executable file that you could compile from source if you wanted to see the actual source, but I'm assuming you don't, so you can just use the executable. And there's a lot of information about that online. I will be using the ODBC after saying I wouldn't. I will be using it for SWM, but it'll be in a more formatted version. And then I'm going to just be using batch files in VBScript. And I chose that over something that's more powerful like PowerShell or Python because there are basically no requirements. And so what I wanted is something really simple. So you see the method here is drag and drop. So you'll take the file that you need to move from one to the other, drag it onto the batch file, and it will do all the work for you, and you repeat as you need to iterate through your processes. Again, you could install Python and run it, but I try to keep it simple. By all means, you could extend this if you'd like and use something like Python, but for now we just try to keep it simple because again we want the requirements to be basically nothing. If you're using a Windows 7 machine, 64, 32-bit, even XP honestly machine, Windows XP, as long as you have some type of installation of Microsoft Office, which I think is a pretty reasonable requirement, you can run the two with each other. And the final thing to say here is everything again is plain text. It's all hopefully straightforward. You can see exactly what it's trying to do and how it's trying to accomplish a workflow. And I'm licensing it as Creative Commons Share Alike by Attribute, which basically means you can take all the tools that we'll reference at the end and do with them whatever you will. For fun or for profit, it doesn't matter. Just give like attribution back. You can find information on that license online. It's a very non-restrictive license because we are trying to empower people to be able to use the software as efficiently as possible. So all that being said, after about 10 minutes, let's get into the first demonstration. And the first demonstration will be the most straightforward from a data transfer standpoint, which would be going from EPA SOAP to XP-SWM. So what we'll do here is show a SOAP project that is already done and how we can get all that data from SOAP directly into XP-SWM as efficiently as possible, following all those steps we had before. Okay, so let's go ahead and do this workflow of SOAP to SWM. I should stress that the actual conversion takes about 15 seconds, but I'm going to show you some things on either side of it just so you can understand. To begin with, this is a basic SOAP model, if you will, with some rainfall data. I'll show you here because I put in a northing and easting. I will do a little bit of GIS work as part of my conversion because it's quite easy to do. Same thing with flow monitoring data. I have two flow monitors that you'll see there, line 1 and line 3. And then you can also see some RTK parameters. And those are also things we want to get over. So you recall, we want rainfall, we want flow, we want RTK. So I mentioned it's a simple drag and drop. I'll show you what that looks like. This is that source.sdb. This is my example file. I have my elegantly named drag SOAP onto me batch file. So that's what I'll do. I'll take it and drag onto it. And what will happen is it'll open up a couple different batch files and basically run the conversion. And at this point, honestly, the conversion is actually done. It's doing some final cleanup, but the actual conversion is complete. So let me bring over something it generated on a different screen, which is basically just a simplified web view of the data. This is all GIS or spatially related because I happen to put a latitude and longitude on my rainfall and flow meters. This isn't required, but it's nice data to have to help make your SOAP data look a little better as part of your workflow. You can see online, so if I click on flow meters, I get an online map that has where this meter is, and that's something that I can share either by way of email or save even directly here in different formats. So I can save it in lots of different formats just right here. It's not a lot of data there, but it's pretty easy and it's pretty quick. We also have KML that's easy enough to generate. So you can see here I already have the gauges on there, but if I go to my output, I could also add the meters. I'll just drag it straight here and you can see the meters are added. So those are the same meters in a better spatial representation than what you can see in SOAP. And so if I click on one of these, I can actually even view the gauge directly here. Again, not necessary, but it's nice to see. So you can see the rain gauge data directly in Google Earth. I'll close that now. And you also saw here shapefiles. So if shapefile is more your thing, then you can also bring a shapefile directly into a GIS. But the purpose here is really to get SOAP out of SOAP and into XP-SWM. So let's go ahead and do that. So I'm going to go open up an XP-SWM. So I'll start from scratch and use a template. And in case you haven't used a template before, it's quite simple. The first thing I need to do is specify a file for my new location. So I'm just going to put something in a temporary location. And now I need to actually go find my template. In this case, I have my template over where I put this, which is in my output. Everything I need is in this output folder. So you can see this source.xpt. So now we have what would appear to be a typical installation. So now you have what would appear to be a typical XP-SWM file. But if you're not familiar with the merging and templating, we actually have a few things that hopefully will be of value to you if you are bringing SOAP in. And I'll show you those. The first are some new global datas. So if you look at global data under rainfall, you'll see there are two gauges predefined. Those are the two gauges we just got out of SOAP, and we'll use those in just a minute. And if we also scroll further down to user-defined file types, we have SOAP rain, which is actually used in our rainfall, and then SOAP flow, which we will use here in hydraulics. The other thing we have under tools GIS link or you can get to that by Tools, Import, Export, External Databases, is our RTK patterns. So we also have those as an ODBC. You see the configuration, that's predefined as a SQLite database. If you look back on our output, you can see here it says need help setting up ODBC connections. So if you need help with that, it's not going to be covered right now, but you can cover that. That's a one-time thing that you'd set up, and then you'd have this every single time. If you look under mappings, you can see that the R, T, K, and all the antecedent parameters are already predefined, as well as how we choose in this case to import or export. It's already set up for us, which is really nice. Let's go to hydraulics and add those 2 meters. Of course, there's lots of different ways that you could add those meters. You could add the meter as data in a node, or you could add it as data in a pipe. And even within those 2 different object types, there's different ways to actually add the data. That's beyond what we're trying to cover here. I'm just showing you how to get the data in and out, and you can customize that for your own needs. So let's assume we're just going to use gauged inflow. File format would be SOAP flow, and then we'd select the data. In this case, it's under output for XP-SWM, that would be flow. It's a CSV file. The convention here is meter and then an integer after that for however many meters you have. That defines the station as well. I hit OK here. I could add the second one. Same idea, gauged inflow. Select it in output, XP-SWM, flow. We'll go to meter 2 just to show you what that looks like. If I go to file format flow, I could edit that. It's going to now use my user-defined SOAP flow and point it to the CSV, which again is always the same looking. So if I graph that, it will always look the same. Always have flow and time, exactly how it is in SOAP. Hit OK, OK, and OK. And of course you could build this however you'd like, however this model ends up being built. You know, again, not necessarily something to be created here, but that's something you could do. So perhaps it's something looks like that. Now let's assume we are going to use our flow data with some rainfall data, of course. That would be useful to use the full power of SWM. We'll just add 2 new nodes. And of course, when I pick my rainfall, I can just pick the rain gauge. Really easy. There are also different ways you could do rainfall, but in this case, that's predefined, so I don't really have to do the work. If I were to edit that, you could see it's just a user-defined file with the file format SOAP rain pointing to the gauges based on stations. Real straightforward. Again, since it's repeatable, we know exactly what it's going to be every time. There's no guess as to what that might look like, and I could have edited and shown you that data as well. From here, of course, you would build your whole network as you want it, or you may already have your network defined. If that's the case, then you could still import everything from SOAP and just point the global data to where it belongs. Same idea when we go over here to our importing. So we could import all of our RTK patterns to be able to run wet weather, should we be running it that way. Or perhaps you have a combined system and you might use both datas in different ways. Again, the possibilities are really not to be limited by this demonstration. I'm just showing you the best way to get the data from one to the other. And so that's the first workflow, which is getting data out of SOAP and into SWM. Again, real simple, takes about 15 seconds and you're off and running. Let's say that we extend this workflow and make some changes. We change the RTK parameters by looking at some hydraulics elsewhere in the system. Well, that's pretty straightforward, right? Because we could export this data back out to the SQLite database, and then we'll show how we can get that data back into SOAP. We may have the more complex version where we have a brand new XP-SWM installation and we're running it, and we need to get brand new RTK patterns that don't exist, or more importantly, we have rain and flow data that SOAP hasn't seen yet. So we need to export that data back out of XP-SWM and into SOAP. So that's the second of 2 workflows that we'll cover right now. And we will start by going back to the same location in the file system as we were before. Notice we just covered drag SOAP onto me. And so the workflow we just finished obviously has a connection between XP-SWM and SOAP, and the SQLite database exists. So if we were to go back and forth and pass data back and forth, we wouldn't have any problems. However, if we completely started from scratch in XP-SWM, we wouldn't have the SQLite database. It just wouldn't exist yet. It wouldn't be formatted correctly. So we do have a little button here that says Create New Converter. And in this case, it says I already have the database because I just ran everything. But if I didn't, it would make a copy of a one from source that we could use. The other thing we did is file for merging. So in this case, again, we don't need that because we already have everything established correctly. But if you had an existing file, then you could merge that .xp file in, and then you would have the same databases. So let me show you what that looks like. I've just opened up XPSWM, and I will go to a file, and let's pick a file here that's a sanitary file. It doesn't have any of that configuration we had before. So global data, say rainfall, we don't have any of that there. So what I can do is merge, and I'll go ahead and merge my global database, and I will pick over in output again. In my output for XPSWM, I see this SOAP.xp. Do that and merge it. If I go to Tools, I'd have my GIS link set up there, and if I go to Configuration, Global Data, you'll see my gauges are all there. So I have everything set up the way I need it to, as well as the database. The database is there, so even in this file, which has no SOAP integration at this point, I'm now ready to export data as RTK or as flow and otherwise. So how do I do that? Well, I'll go back over to my file system, and I don't have to drag anything this time because I've already established where everything is. I'll just hit convert. So let's go ahead and press that and see what happens. So let's discuss what we just did, and it's relatively simple. We generated a new Microsoft Access database. We populated that database with basic information from an EPA SOAP database, and then we also inserted new information from our XPSWM database. The new information are the RTK parameters, flow and rainfall information, as well as any other information you choose to insert. In this simplified example, I don't have anything with that. So let's see if we can open up the new file we just created. And I'll do that by going to the SOAP toolbox. I'll go ahead and maximize this. I will say open, and I will go and tell it to look for all files, and you'll see this .mdb file. And sure enough, it can open it even though it's an access file. And so the more data that you're transferring back and forth, the more that will be in SOAP. And again, you can analyze and then go back and forth and continue passing data back and forth. One last thing to cover is a more technically difficult subject, which is the best practice for moving flow or rainfall data from SWM to SOAP. Again, SOAP stores everything in row column in the database. XPSWM is more flexible. It can store pointers to actual data like a CSV or text file. It can also hold constant or variable time input text directly in the file. So that flexibility is very useful to the user, but can make it more difficult to build a standardized workflow to get the data out. There are two basic ways I'd recommend doing it. I've implemented most of the solutions already, but in my interest of not using Python or another higher level program, it gets a little more cumbersome to set up everything in a batch file. So the two ways depend on what type of data you have. And I'll show you those briefly. Here's an example where I might have time stored directly in the program. And here's a different example where I might be storing a reference to a file in the program. If I'm storing a reference to a file, I've written the majority of a batch file script where you can point the reference file and it will actually parse the data for you. And again, that can be difficult based on the different columns of data. It actually does the entire job if you have data in a couple separate formats. However, if you have data in this user-defined, whether it's constant or otherwise, flow or rain, your best bet is actually to go into File, Export, EPA 5, and that will export it into a .imp file. You may have seen one of those files in the screen capture earlier. There's also a tool to grab that file and pull it in. So if you're doing internal data, use this EPA 5. If you're doing external data, use the script that I'll have as part of this. The other option you have is to go into Review Results and export that as text data either to a clipboard and paste it into Excel and save it, or actually to its file itself, where you can specify some of the data. Any of those are really valid, and the level of effort required to put those together and also be flexible enough for all the different types of parsers and input steps is really beyond what I'm going to cover in this. Sufficient to say, though, it is something that wouldn't be too difficult to do, and I encourage you, if you have the same type of data, perhaps from the same vendor of flow data or otherwise, then it's probably worth the time to do it. Okay, so we'll conclude now and be under half an hour, I think, which is good timing for me. So the softwares can natively interact. Hopefully you've seen that. You can get data in and out of SOAP and SWMM relatively easily. You could always do it relatively easily manually, but now you can do it even more efficiently automatically. This presentation basically was meant to outline some workflows that would make more sense to the average sanitary sewer user. After outlining the workflows, we demonstrated some of those in basic terms. Again, the idea is not to build another piece of software the level of XP SWM, but to show you some workflows, and as such we had some basic workflows with some actual demonstrations. You can have and modify the code. So the code that you saw and the source files that you didn't see are all available to you. Just get in contact with me and we will discuss what's best for your use case. Here's my contact information. Drop me a line if you have any questions about this or any other presentation I've done, or if you have any questions or just want to talk about sanitary sewer. Thanks a lot. Bye.